All right, 7.2 today, we are going to talk about central angles, arcs, and arc lengths. So we're going to add some more information about circles today. Central angle is an angle formed by two radii, and its vertex is at the center of the circle, which makes sense because it's called a central angle. So an example would be ACE, angle ACE. My vertex is the center, so that's at C. And then the other thing I want to note is that the angle, the central angle, and the arc that has matching endpoints are equivalent in measure. So this is 45 degrees there. Then we talk about a minor arc. It's an arc with a measure less than 180 degrees. So when we're talking about the arc, we're just talking about on the circle from point to point. So this one would be like DF, and we name it by the endpoints, and we put an arc over the top of it. So 60 degrees here. Then if we talk about a major arc is an arc with a measure greater than 180 degrees. So for example, I'd have E all the way around to A again, but we wouldn't just call it arc EA or AE because that could imply that small piece inside. So we need to start with one of the endpoints. So I'm just going to say E, and then I'm going to pick a point that I go through. So I could say EBA for this. So a major arc is going to be named by 3 letters. I would never name it with more than 3 letters, but that green arc I have marked, I could call it EBA, EFA, EDA. And then I could go reverse. I could say ADE, AFE, ABE. All of those are denoting the same exact thing. And then last we have a semicircle, and that's an arc with a measure equal to 180 degrees. So for example, all the way from E to D would be a semicircle. Same idea as with the major arc. I need 3 letters to denote what it is so that I know which side of my arc I'm talking about. So E, B, D, and we toss an arc over the top. All right, so then this right half here, we're going to use that circle, and we're going to find the measure of each arc and the angle that are named. So I'm just going to like clear this up a little bit here. So that angle is 45 degrees there. This one here is going to be 60 because the angle and the arc have the same measure. Now, ED is a diameter, so it splits this circle in half. Now, circles are 360 degrees total, so that means each half is 180 degrees. So to find my other portions, like my left side, I'm going to take 180 and I'm going to subtract 45, and that gives me 135 for that angle. And then on the right side, I'm going to take 180 and I'm going to minus 60. So I get 120 degrees there. Now, keep in mind the arcs are the same measure as the angles. Oops, 20, not 30. All right, so this first one says measure of angle FCD. So F to C to D is that angle, so it's 60 degrees. And the only kind of angle we've talked about today is a central angle. So this is a central angle. All right, now it says arc AE. Arc AE, it's going to be 45 degrees. Because that's less than 180, this is a minor arc. All right, let's look at another one together. Measure of arc ADF. So A to D, oops, wrong way. And you know how I knew the wrong way? Because I was going to run into F before I ran into D. So A, D, F. So here I'm going to add the 135 and the 60. And so I get 195. That's greater than 180, so this makes it a major arc. All right, I want you to go ahead and pause the video here and finish filling in the last 5 of them. And then when you come back, I'll have them done and we'll compare. All right, so go ahead and check those. Hopefully you got the same thing. All right, find the measure of angle HDI, H to D to I. Now, if you look here, I have those 2 little red marks there. Yours might be black on yours, but just a reminder, those mean that those angles are congruent. So we see our arc is measured at 53, so my angle is 53. And if one is, the other one is. So now I'm also going to notice that IF is a diameter. So I'm going to take 180. Oh, that is really probably hard for me to see. It might be hard for you to see also. Minus my 53, minus my 53 to find out the angle HDI is. And you end up with 74 degrees. All right, I think that on your homework it says HEF. So I'm going to look HEF. You're either talking the angle or the arc. They're the same thing. All right. So I think you said I maybe on your homework. So a circle is 360 degrees. We know that this is 127. The other one is 90. So go ahead and take 360 minus 127 minus 90. And we find 143 degrees. Now that holds true for the angle or the arc, so it doesn't really matter which one we were finding. All right, so let's go ahead and talk about arc lengths. Arc lengths, it's the ratio of the length of the arc L to the circumference of the circle equal to the ratio of the degree measure of the arc to 360. Sounds really simple, right? Usually when I read that, people are like, whoa, that's a lot of words. But let's just break it down. It's a ratio. Remember, a ratio is a fraction. It's the arc length, L, to the circumference. And circumference, we can either use 2 pi r or d pi. We learned that in 7.1. So I'm just going to write 2 pi r. Just keep in mind, we can interchange that with d pi. It's equal to the angle measure. And if we look at our example over there, we're going to call that x over 360. So it's two ratios equal to each other. Most of the time we are going to be solving for L. So you can certainly set it up like this and cross multiply. But what I'm going to do is we're going to solve this so it's L equals for our formula. That's just a little easier for us when we already have our length solved for. So it says L divided by 2 pi r. So I'm going to go ahead and multiply by the circumference on both sides. So I have x over 360. It's going to be times 2 pi r. Remember, that could change to d pi if we're given the diameter. So, perfect. Let's go ahead and utilize this now. In this problem, it says find the length of zy. So what we're talking about here is when we talk about the measure is equivalent to the angle. But when we're talking about the length, that's if I take that blue line that I just drew there and I lay it out straight and I actually measure it in inches or in centimeters or feet or whatever. That's the distance I'm finding, not the measure of it, which is the angle. I'm finding the length of it. So that's in distances. So we're going to plug this in. So L equals, my length equals my angle measure over 360. And then I'm going to times it by, and this, they give me a radius, so 2 pi times 4. So go ahead and grab your calculator. Make sure that you're plugging the 75 divided by 360 in parentheses when you plug it into your calculator. And then let's agree to just round to 1 decimal place. So in this one, our length is 5.2. All right, let's go ahead and set up our next one. So our length equals, here we're finding EF. And so we have 120 over 360, oops, sorry. And then 2 pi times my radius is 6. Again, they gave me a radius, so I'm going to write 2 pi r. Typing that into your calculator, you get 12.6. All right, so now for our two word problems we see here, we are going to say it says we have a circle who has an arc with a measure of 80 degrees. Okay, so we have our angle measure, whose arc length is 276.46 pi. This time we are given L. That's what L is. What's the diameter of the circle? So we have to solve for D. So 276.46 pi equals my angle over, now instead of 2 pi r, I'm going to write d pi because we're looking for our diameter. So the first thing I notice is I have a pi on each side of the equal sign, so I'm going to cancel it. That doesn't always happen. You're just going to want to pay attention when you are looking at your length. All right, so 276.46 equals 80 over 360 times diameter. You have two options here. It's 80 over 360 times the diameter, so I can divide by 80 over 360 on both sides, or Dividing by a fraction is the same thing as multiplying by the reciprocal. So you can choose if you're going to divide by 80 over 360, or if you're going to times by 360 over 80. This is equivalent. You just have to decide which one you want to use. So let's go ahead and round to 1 decimal place. You guys got a really small number, right? Just kidding. You have 1,244.07 inches for your diameter. All right, we got one more here. This time, they give us the length and they tell us the radius, and we are finding the measure. So let's set this up together. 33.98 pi equals, I'm finding my angle, so I put an x over 360. And then they give me my radius, it's 18, so 2 pi 18. All right, again, sweet, this time they give us both pi's on each side. So I get 33.98 equals x over 360, and then 2 times 18 gives me 36. All right, so we have x divided by 360 times 36. So you can go ahead and divide by 36 on both sides. And we get x over 360 on this side. This side goes like 9.4, blah, 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 and it just keeps on like running. Leave that on your calculator and then just times it by 360 on both sides. Don't round it. If it's in your calculator, just use it. All right, we end up with 339.8 degrees for this, okay? So somebody pointed out one time when we were talking in class, they're like, well, all I'm doing is moving the decimal place, and that comes in right here. If we take that 36 over 360, that really reduces to 1/10. So you could say 33.98 equals x over 10, and then you're just multiplying by 10 on both sides. So that's how that ends up working out that way. Multiple ways to get there. All right, thanks for hanging in there. We'll see you later.